This question is about capacitors and how their charge and electric field strength changes when you have a dielectric. So you have a pair of parallel plates that you connect up to a supply, which we'll set as a voltage V, and we'll actually call that initial voltage, we'll call it V1. That V1 will cause charge to build up, so charge to separate. So charges will separate. So they will separate. So the positive charges will be attracted to the negative side, and the negative charges will be attracted to the positive. In reality, it's just the electrons that are moving. So electrons will move away from this plate, and you'll end up with this plate being positively charged and this plate being negatively charged. So the electrons will move away from this plate onto here, and whatever the voltage is here, we'll have this voltage will be across the plates, and the charge stored will be equal to the capacitance of the capacitor multiplied by the voltage applied. Now, if you put in a dielectric, these values can change a little. So the electric field strength here is due to the difference in the positive charge here and the negative charge here. So we'll have a potential difference across the two. And the electric field strength will be equal to V over whatever the separation of the plates is. If we put a dielectric in, a few things happen. So having a dielectric in between two capacitors increases the amount of charge you can have for a certain voltage. So putting in a dielectric, you have this polar material, and this polar material will arrange itself with pluses and minuses. So this side, you'll have the dielectric arranging itself so the pluses are on this side and then minuses are on this side. And they will actually weaken the overall electric field strength. So the overall electric field strength will reduce because of these extra charges diminishing the effect of this charge separation. So you will reduce the electric field strength across the capacitor. That also reduces the voltage. So the voltage, now if we disconnect the supply, the voltage now drops slightly to V2. Now the charge stored is still the same. It's still Q, but now we've got a different capacitance. So where we had a lower capacitance C1 and V1, we've now got a higher capacitance but a lower voltage because the charges stay the same. So you can do a little bit of research and get into this in a bit more detail, but then you start going off into content that's beyond A-level, that's beyond the requirement of A-level. The simple version for A-level is that the electric field drops due to the effect of these polar molecules within the dielectric itself. That reduces the electric field strength, and it will reduce the voltage, the potential difference across the two plates, but the charge stays the same, and that is facilitated by the capacitance changing. So introducing the dielectric increases the capacitance as well.